Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's evaluate the limit of this given special function e to the power of t minus 1 all over t as t approaches to 0 using table of values. This is another special function. It's considered to be a special function because as you look for the limit of this, the limit exists. We have here our function, let's say f of t, because we are using t as our variable, is equal to e to the power of t minus 1 over t. Okay, so we are to solve for the limit of e to the power of t minus 1 all over t as t approaches to 0. The limit of this special function exists, but it cannot be solved using f of c, where we substitute c on our given function, because we always do this. Okay, we always do this for polynomial functions, f of x as x approaches to 0, or in this case, since we're using t, we substitute t here as t approaches to 0. Oftentimes we simply substitute c for our given function and we declare, again for polynomial functions, that they are equal. But this is not true, and it's not the case all the time. We have a video discussing that, and this is further an example of this, because as you substitute f of 0 on our given function, this will become e to the power of 0 minus 1 over 0. Well, our denominator is already 0, so we are leaning towards limit that doesn't exist. But when you look at our numerator, e to the power of 0 is 1 minus 1 over 0. We will get an indeterminate form. Again, it's an indeterminate form, one of the complicated forms in calculus. Hence, again, this is not true, but the limit of this said function exists. We can verify that as we illustrate the limit using table of values. So we pick values from the left and right of 0, and we see the value of f of t, or what is the value of f of t is approaching to determine the limit. But of course, we do that by two sides. We are going to look for the values of t from the left and from the right. So we use here t, okay, and f of t. Supposedly this is x and f of x, but since we use t in our given, so we will be using here t. But nevertheless, the point here is we pick the values of t from the left of 0. So we can use here negative 1, negative 1/2, and negative 1/10. And plug that in on our given function, and let's see the trend later. For negative 1, as we substitute negative 1 or our given function f of t, approximately in 4 decimal places, you have 0.6321. Please verify this using your own calculators, as I'm also using mine to verify the result, approximately in 4 decimal places. Okay, but this is not yet enough to declare that the limit exists, so we look for other values. We have negative 1/2 or negative 0.5. As we substitute that on our given function, approximately we will get 0.7, 8, 6, and 9. We could see a trend now, but let's complete it further by applying negative 0.1. On our calculator, we'll get an approximated value of 0.9516. As you can see, there is a trend. Okay, but to further solidify our trend, let's include here even smaller values closer to 0. Let's have negative 0.01 and negative 0.001. Okay, as you apply negative 0.01 on our given function, approximately in 2 decimal places, you will have here 0.9950. Okay, and as you will try the last value, approximately you will get 0.9995. Using these values of t getting closer to 0 from the left, we can see that our f of t gets closer to 1. This is the limit from the left. Okay, now let's see. Again, this is the limit of e to the power of t minus 1 over t as t approaches to 0 from the left. Let us try to use these values from the left, from the right of t now. So since it's still 0, we'll be using the positive of these values. So you have 1, 1/2, 1/10, 100ths, and 1,000ths. Okay, now let's substitute them on our given function. As we apply 1 for our f of t, approximately, we will get a value of 1.7183. Okay? As we apply that on our given function. So we can see this is not the same as this, or even the opposite, as different from the previous two videos, because our function here contains exponential form. Okay, now let's continue with our 1/2. As we substitute 1/2 on our given function, we will get here an approximate value in 4 decimal places, 1.2974. Continuing to 1/10 or 0.1, we will have approximately 1.0517. We can see a trend here now, but of course, let's use these smaller values, even smaller values. You have 100ths or 0.01, plugging that in our calculator for this given function. Again, clarification, you will have here approximately 1.0050, that's in 4 decimal places. And finally, for 1000ths or 0.001, you have approximately 1.0005. Now, as t approaches to 0 from the right, you will get a value of f of t getting closer to 1 as well. So the limit of e of t minus 1 all over t as t approaches to 0 from the right is equal to the limit from the left, which is just equal to 1. And this is the limit of this special function. See, we have an exact value different from the indeterminate form using f of c. This is called special function for that instance. As we will be using this special function soon, we may observe that the limit of that is just equal to 1. Thank you very much for watching. So what are you waiting for? Subscribe now.